Ever wondered if everything you've heard about space is true? Today we're taking a cosmic journey to debunk some common space myths. It's vital to sift fact from fiction, especially when it comes to understanding our universe. After all, scientific knowledge is our best tool to explore the cosmos. So, buckle up, space enthusiasts, as we navigate through 10 popular myths and reveal the astronomical truths behind them. Prepare to have your mind expanded beyond our planet as we delve into the universe's truths. First up, the classic myth that the sun revolves around the Earth. Historically, people believed in geocentrism, the idea that Earth was the center of the universe and everything, including the sun, revolved around us. It's a comforting thought, isn't it? But then came along Nicholas Copernicus in the 16th century, who introduced a revolutionary concept. He proposed heliocentrism, a model where Earth and the other planets orbit around the sun. This view was later supported by further astronomical observations. So, contrary to the old belief, it's not the sun that takes a daily trip around us. Instead, we, along with our celestial neighbors, are the ones doing the circling. So, it's not us at the center of everything, but the sun that holds the pivotal position. Next, let's tackle the myth of black holes as cosmic vacuum cleaners. Imagine a black hole. It's mysterious, it's intriguing, and it's incredibly powerful. But contrary to popular belief, black holes aren't the universe's equivalent of a Dyson on overdrive. Yes, they possess a gravitational pull that's off the charts, but that doesn't mean they're out there, sucking up everything in sight. Their influence is not limitless. It's determined by proximity and mass. A black hole doesn't exert more gravitational force than any other object of the same mass. It's just that all its mass is concentrated in an infinitely small point. So remember, black holes are not cosmic hoovers, hoarding everything in their path. Moving on to the famous Big Bang. Was it really an explosion in empty space? Well, contrary to popular belief, it wasn't. You see, when we talk about the Big Bang, we're not referring to a traditional explosion, with matter flying out into pre-existing space. Instead, think of it as the rapid and immense expansion of space itself. At the very beginning of everything, all the matter and energy that make up our universe were condensed into an incredibly tiny point. Then, in the tiniest fraction of a second, space began expanding at an unimaginable speed, creating the universe we know and are still exploring today. So the Big Bang was a cosmic expansion, not a fiery kaboom in the void. Now, let's shed some light on the sun. Is it on fire? Quite the contrary, the sun's energy doesn't come from combustion, but rather from nuclear fusion. This powerful process takes place in the sun's core, where temperatures reach millions of degrees. Here, hydrogen atoms are squeezed under immense pressure, causing them to collide and merge into helium. This nuclear reaction releases an enormous amount of energy in the form of light and heat. It's this energy that lights up our skies and warms our planet. So the next time you gaze up at the sun, remember it's not a huge flaming ball. The sun, our radiant star, is a nuclear marvel, not a massive bonfire. Up next, the myth that space is completely empty. Picture this: vast expanses of nothingness, a void devoid of matter. But is this depiction of space accurate? As it turns out, not quite. While it's true that space is a vacuum, meaning it lacks air and atmosphere, it's not entirely empty. It's dotted with cosmic dust, interspersed with gas, and even hosts occasional particles here and there. These cosmic constituents, though sparse, give space its unique nature. They're the building blocks for stars and planets, the canvases for nebulae, and the seeds for galaxies. So while space might seem desolate, it's teeming with potential, waiting for gravity to weave its magic. Space, it seems, is not as empty as we once believed. Now we're going to debunk the myth that there's no gravity in space. It's a common misconception, largely due to images of astronauts floating weightlessly in their spacecraft. But don't be fooled. While it's true that astronauts in orbit experience a sensation of weightlessness, it's not because there's no gravity in space. Gravity is a universal force, present everywhere in space. It's what keeps the planets in their orbits around the sun, and it's what gives structure to galaxies. Even in the vast emptiness of space, gravity exerts its force. The reason astronauts feel weightless is because they're in free fall, constantly falling towards Earth, but also moving forward fast enough to keep missing it. It's a bit like being in a lift when the cable snaps. You and the lift are falling at the same speed, so you feel weightless inside it. So, remember, gravity is not just an earthly phenomena, it's a universal one, reaching across the cosmos and shaping the celestial bodies we gaze upon. The myth of no gravity in space? Well, consider it debunked. Next up, let's debunk the myth that sound can travel in space. When we watch sci-fi movies, we often hear loud explosions, laser blasts, and the roaring engines of spacecraft echoing through the cosmos. However, in reality, space is silent. The reason is quite simple. Sound waves need a medium like air, water, or solid materials to travel through. Space, on the other hand, is a vacuum, almost entirely empty of matter. So there's nothing for sound to travel through. While spacecraft and astronauts can produce sound, it doesn't travel into the vacuum of space. The only way astronauts can talk to each other is through radio, with the sound converted into radio waves, which can travel in a vacuum. So the next time you watch a sci-fi movie, remember in space no one can hear you scream. The myth of sound in space, debunked. Let's now journey through a chilling myth, the belief that you'd instantly freeze if exposed to the vacuum of space. Many of us have seen scenes in movies where characters are instantly turned into human popsicles in the icy void of space. But is this really what would happen? Not exactly. While space is incredibly cold with an average temperature of -270.45 degrees Celsius, you wouldn't freeze instantly. This is because there's no air or water in space to draw heat away from your body. Instead, you'd slowly lose heat through a process called thermal radiation. The bigger immediate threat would be the lack of air and pressure, which could have fatal effects within a minute. So while space is indeed a hostile environment, it's not quite the instant deep freeze it's often portrayed as. The myth of instant freezing in space? Consider it busted. Buckle up as we venture into another popular myth, the densely packed asteroid belt. In many sci-fi films, we've seen spaceships dodging and weaving through a cluttered field of asteroids, suggesting a perilous journey for any spacecraft. But how close does this come to the reality? The truth is, asteroids within the asteroid belt are spaced incredibly far apart, with an average distance of about 600,000 miles between each one. Spacecrafts have, in fact, navigated through the asteroid belt without even the slightest risk of collision. So, the asteroid belt, contrary to the cosmic obstacle course often depicted in cinema, is not nearly as densely packed. Another space myth? Consider it navigated and busted. Now let's illuminate the myth of the moon's dark side. Contrary to popular belief, this elusive side of the moon isn't shrouded in perpetual darkness. In fact, it receives just as much sunlight as the side we see from Earth. So why the misnomer? It's all about perspective. From our vantage point, we only ever see one side of the moon due to its synchronous rotation. This leaves the far side, often referred to as the dark side, hidden from our view. But remember, its darkness refers to our lack of knowledge and visibility, not a lack of sunlight. So the next time you gaze up at the night sky, remember, the dark side of the moon, not so dark after all. Well, that was quite a cosmic journey, wasn't it? We've debunked myths from Earth's relationship with the sun to the true nature of black holes and the elusive dark side of the moon. Each fact we've uncovered underscores the importance of scientific curiosity and knowledge in understanding our universe. Remember, space may be vast, but it's filled with wonders waiting to be discovered. Don't forget to like, share, and subscribe for more myth-busting science content. Until next time, keep looking up and questioning everything.